Hey, it's Randy. Let's talk about how to evaluate logarithms. As time goes on, you'll see that solving exponential equations becomes a lot easier when we know how to use logarithms. It's actually a lot less scary than it looks. Here we go. So here you can see that I have two equations written. This first one would be stated as log base b of y equals x. And what's interesting is that this second equation, which is an exponential equation, is actually saying the same thing. So we would describe this second one as b to the power of x equals y, right? So you might be wondering, how in the world are these two equations saying the same thing, because they look totally different? Well, let me describe this logarithm right here and the rest of the equation equals x in words, and then you'll see how it's really saying the same thing as the second one. So when you see log base b of y equals x, that's just saying that this b to the power of what, in this case what corresponds to x, equals y, okay? Now, what's the easiest way to express that whole sentence? Well, it's really just with an equation, right? Because right now we're just saying b to the power of what equals y, the exact same thing. So when you're trying to evaluate a logarithmic equation like this one, at least in the simple examples like we'll see today, it really helps to convert it to an exponential and then try to figure out what is the value of x. Okay, enough abstract discussion. Let's look at some actual examples using this logic. So we need to evaluate the following four logarithms. Let's say for each of these equals x equals x equals x equals x, so that it looks like what we had above. All right, we'll start with this first one. In our first part of the video, what were we really saying? We were saying that the base b to the power of what is on the right side equals that last part of the logarithm. So that's the same as saying 2 to the power of what equals 16. All right, just like this next one is saying 9 to the power of what is equal to 729. And this next one is saying 9 to the power of what equals 3. And this last one is saying 125 to the power of what equals 5. All right, back to this first one. 2 to the power of what is 16? How about 2 squared? No, not 2 squared, because 2 squared is 2 times 2, or 4. How about 2 to the third? Or 2 times 2 times 2? Well, 2 times 2 times 2 is 8, so also 2 cubed will be no good. How about 2 to the power of 4? That's it. 2 times 2 times 2 times 2 is in fact 16. So our value for x in this case is 4. All right, there it is. Now, 9 to the power of what is 729? We know that 9 squared is 81, and that's not 729. But what if you do in your calculator 9 times 9 times 9? Or 9 cubed? You do in fact get 729. So our value for x in this second example is obviously 3. Okay, now it gets a little bit more interesting. How do we go from 9 to 3? Okay, ultimately we do want to answer the question 9 to the power of what is 3? But just think about it. What do we do to 9 to get 3? We take the square root, right? Okay, hopefully you see what's happening. If we know that the square root of 9 is equal to 3, is there another way that we could write square root? Yes, there is. How could we write square root? We could write that as a power of 1/2, which just showed us what is the value of x. 9 to the power of 1/2 is 3. So x is 1/2. Okay, last one. We have 125 to the power of what is 5? Okay, let's think about this. What do we do to 125 to get 5? How about the square root? If we do the square root of 125, we get like 11.18. That is not 5, so we can't do the square root. So next, think about what is the value of 5 times 5 times 5. 5 times 5 times 5 is in fact 125. So we're getting close. One way to think about it is to go from 5 to 125, we cube the 5. So in the opposite direction, to go from 125 to 5, what do? We do the cube root, right? The opposite of the cube. Okay, nice. Now we're really close. So remember, there's like an invisible 1. There is an invisible 1 on this 125. So how could we rewrite this radical expression? Well, that would be 125 to the power of 1 over 3. If you forgot how to do that, just go back to the videos on rational exponents and radicals, and that'll remind you. So 125 to the power of 1/3 equals 5. So what is our x? We now can see that x is 1/3. So log base 2 of 16 is equal to 4. Log base 9 of 729 is equal to 3. Log base 9 of 3 equals 1/2. And log base 125 of 5, we now can see, is equal to 1/3. Okay, so most simply stated, how do we evaluate logarithms? First of all, we just need to convert the logarithmic equation to an exponential equation. And then after that, we just figure out what value of x makes that new equation true. All right, that is everything. See you next time.